Okay, today we're going to cover PowerPoint number three, which is about which covers chapter 3 and 5. Chapter 3 is about normal distribution, z-scores, and also talks about standardized test, or z-score is a standardized test, just one standardized test. And then next time, we're going to go over the basic concepts of probability. There are two different types of z-scores. One for the sample, for the individual, the single score, and one for the research, which we need a sample. So when I say sample, means you got to have more than one person. So one at a time. Let's just talk about single score. Keep in mind, score comes from people. So single score, that means one person score. And we want to know where the person stands. Let's say John Doe scored 130 on IQ test. IQ test is standardized test, but we wanted to know where this guy stands in the population. And for that, z-score tells us. We can tell that uh, he will be 2 standard deviation above the mean or average. So let's move forward and cover this chapter, and you should be able to do your quiz after this one, and then again next time we'll continue and we'll do the second half of this presentation. Back to the normal distribution or bell-shaped distribution. As you can see, that majority of scores are in the middle. That's almost 30, almost really 70% of populations are in the middle. And what you're looking at is IQ distribution. And right in the middle, that 100 is average IQ score. Average normal people have an IQ 100. And the standard deviation for the IQ is 15. So you move up or down 15 points. That's one standard deviation. Just 1 minute. I have to check something. Okay. Everything is okay. All right. So let's move forward. Let me see if I can make this a little larger. All right. Okay. So what are the procedures for standardized tests? What are they? A standardized test is a test that is administered and scored in a consistent or standard manner. Like I mentioned, like IQ, the mean for it is 100 and the standard deviation is 15. That means wherever you go, if you use a so-called commercial IQ test, the mean should be 100 and the standard deviation should be 15. The mean and the standard deviation of the standardized test or inventories are known. For example, IQ test, which I just mentioned, Wisconsin card sorting, that's another intelligent test, and GRE, ACT, SAT, these are all standardized tests, and they have a fixed mean and standard deviation. But then again, somebody take these tests and wanted to know where they stand, the Z-score, which is also a standardized test, tells us where that person stands. And keep in mind, this is a Z-score for single score. So tell one person we're dealing with. And then, like I said, after the probability, we're going to cover Z-score for research. That's when you take a sample of, let's say, participants. And we want to know where they stand. Like, what's the average IQ for the, um, the university that you're attending. And that tells us you take a sample from your university students and you give them the IQ test, and then you gotta test your hypothesis, and it depends on how you're gonna do it. And so Z-score will be the perfect um, test the statistics to analyze your data. We use Z-score for location of scores and standardized distribution. As you can see, once again, the Z-score, it tells us the location of where you stand. And what are you looking at? This is IQ distribution. Again, you can see at the bottom is 100. 100 is mean of IQ. And then up or down, you move 15 points. So 100 is average IQ. And then again, one standard deviation above and below, still average. We call them high average and low average. Now, 200 standard deviation above the mean will be very high average. And then 2 standard deviation below the mean will be very low average. And then again, on the end, it goes extremely high or extremely low score. Here, side by side, you can see the IQ distribution on the right side, and on the left, you will see Z-score distribution. So if you take the IQ test and your score is 120, which is, you can look and you see it's just a little over the one standard deviation, less than 1.5 standard deviation above the mean, because 100 is mean. But again, we're looking at it and we can visually determine that. But the job of Z-score is to pinpoint and tells us the Z that you can see on the blue distribution, what is exact score or location of the Z. And that's what we want to do. Use the Z formula. Again, Z-score is a standardized score, and it has its own characteristics. 3 to be exact. Number 1, the mean of Z-score is always 0. The standardized test, just like mean for IQ, is always 100. We're not talking about some Mickey Mouse IQ test on internet. We're talking about professional or commercial IQ test. Stanford Binet, Risk, Waste, and beyond. Every distribution of Z-score has the standard deviation of 1. So the standard deviation for Z-score is always 1, fixed. Mean always 0, mean always 1. I mean standard deviation always 1. And the shape of the distribution of z-score, it depends. If that's why you need to, when you take a sample from your population, make sure your population are normal. Normal means um, they're not skewed, positively skewed or negatively skewed. For example, if you wanted to find out something about the income of people living in South Beach, you will see there is a big gap between the salary and, let's say, majority are on the right side. Let's say they make over 100,000. So that tells us that is negatively skewed. So if you're not supposed to use that for z-score. You should use it when population is normal, that people like majority or the distribution, like 70% of people in the middle have such income, let's say about 100,000, and then a little more over, and then little on the left side of the curve less than that. That's the normal distribution. But if it's a big gap and then you got all these people making, hundreds of thousands, millions of dollars, and then you get you have a big tail on the left side, people make like 40, 30 or less or something like that. Then if you take average mean, that would tells you that average person probably make about 100,000, and you see somebody and they say they live in a South Beach, and you say, well, your income is at least 100,000. But that's why you're not supposed to. You want to make sure your population that you're gonna draw a sample is normal, normally distributed on whatever you're trying to measure. So because it affects the shape of distribution, the shape of z-score is standardized, is normal or bell shape. So if you get it from positively skewed for negatively skewed, then it's going to affect your z. That means the result's not going to be valid. So z-score transform your standardized score to z-score. We do that because two purposes. It tells us the exact location of the scores within the distribution. Like again, if somebody will take an IQ test and let's say we tell them your IQ is 130, and so z-score tells us exactly where they stand. If they don't know what does that mean, if you calculate, you can calculate where the person stands by using z-scores. And it tells us exactly like the example I gave you earlier. Also, it tells us the scores can be compared to other distributions that also have been transformed into z-scores. So if they take other tests, and then so you can tell them basically on this test, your score is 2 standard deviation above the average. On the other one, you 1 standard deviation above the average, and the other one, you probably half a standard deviation below average. That's the job of this z-score, just this one, for single score. Again, keep in mind there is another z-score that we will talk about in a couple of weeks. So there are other z-scores. There are other standardized scores, as you can see right here. There's t-scores, like MMPI uses t-scores. You take it, let's say on depression, you score 50. So right there, that means you're average. Your depression is average. You're okay. But if you do 60, that means your depression score is one standard deviation above average. And then there are others for different purposes, like a standard 9 or stay 9, and of course percentage, and the others, percentile. This is a percentile. You can see from 1 to 100, and then at the bottom you see the Z distribution with mean of 0 and a standard deviation of 1. You move to the right, increases, the number increase, and you move to the left, the number, which is just one score, 1 point. You go down. This is a Z score. For the IQ, in the middle, you would see 100. And then each standard deviation would be 15. But for Z, it's 1. If you see those lines, multiple lines, those are not standard deviation. As you can see, some of them are standard means fixed distances from mean. Those numbers, if you can see, you read on top of them, those are percentile, okay, or percentage. From 0 to 100, those are not standard deviation. The standard deviation are right there, where at the bottom when the 1, 2, 3, or -1, -2, -3s are. So with that in mind, we're gonna become familiar with the Z and the scores where they locate, the location of scores. For example, this is identify the Z-score value correspond to each of the following location. All right, so this is just for spatial ability, and of course you don't have anything for you like this for quiz. It's just to show you what does that mean when somebody said there's a score below the mean by 3/4 of standard deviation. So you can see that distribution, normal distribution, which I draw with the mean of 0, and then you go to the left is 1 point, and then you go to the right 1 point, negative and positive. But this is just, as you can see, that blue line inward, it's just a quarter of point short of just one standard deviation below. Below means less, so it's right there. If it's just one standard deviation below the mean, then would be that line, that black line. But since it's 3/4, so that's what it is. The other one says above the mean by 1.5 standard deviation. So above the mean is 0. So you see 1, 2 standard deviation above. But right there between 1 and 2 on the right side, right in the middle, that would be 1.5 standard deviation above the mean. So this is, good practice. If you don't know, you can learn it by practicing all those distances. I'm not going to go over all these problems, just to give you some idea. All the formula that you need are here, right here. And the one that I circled in purple, that's the formula for the Z-score. That's how we come out with the Z-score, like where they stand, whether it's positive, can be positive or negative. If it's positive, then it's above the mean. If it's negative, it's below. So right there, you see that score is 10, like somebody's score on IQ is 120. And then x minus mu, that u is mu, Greek letter, and divided by that sigma at the bottom, lowercase sigma, like Hershey kiss. X is 120, mu, which is population mean, which is the mean for IQ, is 100. So 120 minus 100, that would be 20 on the right. And the standard deviation for IQ is 15. So 20 divided by 15 is 1.33. If your IQ is 120, that means you are 1.33 standard deviation above the mean. And you can see it on the very, very right, top right there, the black distribution, and the one underneath it on the right side, on top right side. So going back here, it says for population, mean is 20. For a population, mean is 20. And keep in mind, it doesn't have to be IQ. Any standard population. What you need to know is we use the z-score when, like for research, we use the z-score when we are using standardized tests. Like I mentioned, ACT, GRE, IQ tests, and all that, then the z-score will be the best choice. If not, if you use some tests like depression tests, because depression tests are not standardized, like they have their own cutoff points, like Hamilton depression test or Beck depression test. They're not the same. The score means different. So they're not standardized. So what do you do if you use those tests? Then you use t-test. And t-test is just like z-score. And we will talk about it. And the distribution even is same. We will get to the t-test, and there are 3 different types of t-tests for different research. But for now, let's just focus on z-score. There's the formula, x minus mu, that's all you need, divided by standard deviation. So if x is 18, you put it there, minus mu is 20, that's the standardized test. Some standardized test didn't say what's the name of it. We don't care. It's just a standardized, okay, that's all we need to know. Divided by a standard deviation of that standardized test, which is 4. Okay, so 18 minus 20 divided by 4, that would be the answer. And for the second part, 28 minus 20 divided by 4, which is standard deviation. They're extremely easy. And again, I want you to do these and let me know if you have any question. And like I said, if you send them to me as your homework extra, you would get extra point. But always say that these are not going to be substitute for your SPSS assignments. If you haven't done it, please do so. All you have to do, contact Albicio desk help or help desk, or just talk to either Mr. Martinez, not Dr. Martinez, but Mr. Martinez. He works at IT, or Rudy. And just request for that software. Like I said, I just got it new because it expires in a year. Every year I'll have to do the same. I will contact them and I'll say this expire, and they send me the license code for the new version. And it's good for a year. you need to do the same thing and use it for this class and the next one, advanced statistics. So the sooner you get it, the sooner you do your SPSS assignments, and the sooner you become familiar with it. Once you learn how to do it, it's the same. And as you're going to see, and I showed you in the past presentations, it's always the same. You put your data, numeric information, you go to analyze, you choose your test statistics, click on it, and bam, you're done. All you have to do, I'm not asking you to write an APA style paper. All I'm asking you, once you've done that, take a screenshot from your input, that's you when you put your data in, and your output when the result is, and send them to me. Send those screenshots. Email them to me. That would be the best way to email them to me. So when we look at like this one, already they gave you the z-score, and it says, well, what would be the x-score? Also gives you the mean for the distribution and the standard deviation. The formula is right there. You just plug them in, but I wanted to show you once again. Let me make this larger if possible. Again, on the left, you're going to see the main formula for the z-score. Which is x minus mu divided by standard deviation. X is the score, mu, or that U that you see, Greek U, is population or standardized test, mean for standardized test. And at the denominator, you see standard deviation or sigma, that little sigma. That's the main formula. But if you look down, well, first of all, it says that mu mean, that's mean on population. And you know that we use the mean score, I mentioned that, when we work with the population standard deviation. Like IQ, it tells us about mean for the population, mean or average score of the population is 100, and the standard for the population. But if we have that, we use z-score. If we don't, like I mentioned, for the z-score, for the, let's say, depression test, we don't know what's the mean or average score for the depression in population, because every test is different, have a different mean. So we can't use that. We only use it when we only use the z-score when we work with standardized tests. If not, t-test. And then again, if you have more than one, then you use ANOVA. So once you learn these test statistics, you're going to see that they are related. You'll be able to connect them with each other. So the formula number one is z equal x minus mu divided by standard. That's the main formula. But you can see underneath there's 2, 3, and 4. What they are, we call them derivatives. They are derivatives of the first formula. Derivatives means you can derive formula from formula. This is algebra. And again, if you know it, sure, you can do it. If you don't, it's okay because it's already done for you. What you need to know is if the question asks you about value of the z, number one, then you should know the score. You can know the population and standard deviation mean and standard deviation. Okay, so, and you can see that example we already done, 120 minus 100 on that. But what if we wanted to know, let's say x, we wanted to know what the score is, x. Then I give you z-score and the mean and the standard deviation. Then as you can see, formula 2, which is, that's sigma z in parentheses. That means you multiply those two. Once whatever you get, you add it to mean. And as you can see, for the same numbers, that again, the standard deviation is 15 and z is 2. So you add them up. 15 times 2 is 30 plus mean, which is 100. That come out with 130. That's the score. That's correct. And then in the same token, if I ask you, what is the population mean? That's formula number 3. That's one, this is the one you use. Is equal to x, your score, whatever it is. In this case, right there is 130 minus sigma times z. And sigma, the standard deviation for IQ, is 15. And in this case, your z is 2. That gives you the mean for our test, which is IQ, 100. And the last one, number 4, is if I give you the score and the mean and the z-score, I ask you, what is the standard deviation? You need to know these symbols immediately by heart, because that's, in statistics, we communicate via these symbols. And that's must. If you don't know them, you don't understand what I'm saying. The sigma, number 4, which is like a Hershey kiss, all right? That's the standard deviation from population, and this is how you calculate it. I give you the score, x, which is 130, mean for IQ 100, and z-score, which is 2. And that gives you a calculate the standard deviation for that distribution, which is IQ is 15. And then those distribution on the right side it tells you the location where they stand. Like again, the first one on top, it says z-score, and then there's a cutoff and then shaded in red. As you can see, that's above the mean, and then below that is the distribution for the IQ test with the mean of 100 and standard deviation. And then again, the one with the purple shaded area on the left side, that is 1.5 the standard deviation, okay? With the area that is shaded are on the left. These are really about the next section that we're gonna talk about, probability. But I'd rather to do it next time. But with that in mind, what you need to print this slide, because all you need for your quiz is this here and for the next one. And then further, if you go to the left, it tells you about these distances. We will talk about these distances for probability. As you can see, there's some numbers there at the bottom. These numbers are located in your textbook. If you have any textbook, at the very end of it, there are critical values. So here, these numbers are critical values for the z-score. For each test statistic that we cover, there are critical values. Like again, when we talk about t-test, you're going to look up the critical values for t-test or t. Critical value for f or ANOVA, f factorial ANOVA, and beyond, or correlation R. One other thing I just wanted to mention here is I already talked about it last night. I mean, not last night, last time. You can see that those two different distributions at the bottom right side of your screen, you see the two lines. One it says proportion, the other one percentage or probability. We measure probability with percentage, 1 to 100. So you can see that it's from 0 to 100. But proportion is from 0 to 1. So 50% probability or equal to 0.5 proportion. The reason you need to know that is because once we go over probability, and once you look at the critical values at the back of your book, those numbers are given in proportion. Sometimes you need to convert those values to probability. Like if the proportion, the area is, let's say, 0.25, what would be the probability? 25%, right there underneath. All you have to do, multiply that proportion by 100. On the same token, you should be able to revert that. If, again, if the percentage is 25%, what would be the proportion for that? You divide that by 100, 0.25. And then again, those are different calculation. Well, we will go over that next time. There are more problems. They're all the same. All you need is that slide that I just showed you. You should be able to do it. If you have a problem with any of them, please not text me, but email me. Email me with a copy of the problem and say you don't understand that, so I will do it for you, and with explanations. In a distribution with mean, okay, X score is 48, corresponding to Z score, that what is the standard? So again, use that formula. When it says standard deviation, okay, always read what question is asking you. It says, what is the standard deviation for this distribution? Number one, you need to know what is the symbol for standard deviation. And if you look here, number 4, that little Hershey kiss, that's the standard deviation. That's what they want. So your score, X minus mu, goes on top, and then Z goes at the bottom. And I wrote it down. Oh, right there. X minus mu divided by Z. So there was negative, that would be -2 over -0.5. They cancel each other. Negative, negative will be positive. So this one, what is the mean? Once again, you need to know the symbol for mean is mu. And there's X minus sigma times Z, right there. They want to know, right there is number 3, X minus sigma times Z, and then X, whatever it is, 56, sigma times Z, which is 12 times negative 0.5, and then you subtract them. Again, please do these and let me know. Go over and make sure you understand them. This one, it says a normal shape distribution. When it says normal shape distribution, that means you are dealing with standardized tests. It has a mean, that is the standardized test. It doesn't have to be IQ or GRE or ACT or, Wisconsin card sorting. It says a normal shape distribution. That's the standardized test. It could say a standardized test, but any normal shape distribution, one of the quality of these standardized, the main quality is their normal shape distribution. So that's how you know. Mean is 40, standard deviation 8, whatever the test is. We don't have to know for this purpose. Transform into z-score. The resulting distribution of z-score has, this is very tricky. So it's tricky because it's all about understanding of what I've been saying for last, whatever, 30, 40 minutes that I've been talking. They asking, we have this distribution. What is the IQ? Okay, let's just say we have this IQ distribution with mean of 100 and a standard deviation of 15. We wanted to convert it or transform it into z-score. Okay, that's what we said in the beginning. The question is, what would be the resulting distribution of z-score? A mean and standard deviation. They're asking you, what is the mean for the z-score and what is the standard deviation for the z-score? It's always the same. Always. It doesn't matter what you put on top. Any number, any standardized test with a mean of whatever, and standard deviation of whatever, if you convert it to z-score, that 40 mean will be like 0 for the z-score, because the mean for z-score is always 0. Because that's the mean, just like the IQ I showed you. The mean, if that was 100, mean of 100, then the z is 0. On the same token, it says this distribution has a standard deviation of 8. What would be the standard deviation for the z-score? 1, always. Again, on the same token, if this was IQ test, a standard deviation on top will be 15. What would be the standard deviation for the z-score? Like that picture I showed you, comparing IQ distribution with z-score, it's the same. And I'm going to show it to you again. Right here. It's like saying that we have this distribution, whatever it is, it's IQ, we know, has a mean of 0. If we transform it to z, what would be the mean for the z? 0. And this has the right side distribution has a standard deviation of 15. You go up or down 15 points. If we convert it to z-score, what would be the standard deviation for the z-score? 1, always. That's the whole job of z-score. If you have a standardized score, it tells you your numbers are going to be, z is going to show the location of the score by its own numbers. Like if your IQ is 130, okay, you can see that there's 1 and 2 standard deviation right there. 1, 2. That would be Z. If your IQ is right here, 120 is right there. That's what we said earlier. If you don't understand what I'm saying, just let me know. Or maybe I'll explain it next time in more detail. But I'm sure you understand it. But yeah, you don't know. So that's what it is. Okay, so it says distribution of English, which is red, English exam, and the history exam. The mean for the English exam for this class is 70, that's for the class. And the standard deviation for the test is 4, standardized English test. The history exam has a mean of 65 and a standard deviation 1.5. So the question is, in which one you did better? In which class? Your score is 78 in both classes, English and history. You wanted to know in which class you did better. So z-score will tell you. You calculate the z-score for the English class right there on top, x minus mu divided by standard deviation. Should be like 2. And then you calculate the z-score for the history class, x minus mu divided by standard deviation, which is 28 minus 65 divided by 18. That would be 8.6. In which one you did better? The one that you excel. Okay, I'll show you. Draw. Okay, this is the distribution. Okay, and there is mean for the class, and these are the standard deviation above the mean. You did good in both classes, except in English class, your standard deviation, your z-score we calculated was 2, right there, 2 standard deviation above the mean. But in history, change the color. In history, you went up to 8.6. That means you did super. That's 3, 4, 5, 6, 7, 8. Somewhere like you have to keep in mind that it won't close like that. It's open like that. And this end, same thing. It's open. It doesn't look like it's open. The ends are open, they're not closed. So 8.6 will be somewhere here. You did almost over 8.5 standard deviation above average Joe. So you did superior, but even though you got same score as you did in English. So that's the job of z-score for single score. All right, and then again later we will talk about z-score for research. It has a slightly different formula. Instead of x, which is the score from one person, we use mean, like mean for the sample, m. Instead of x, we use m. We'll talk about that later, but let's just focus on this. So anyway, speaking of IBM SPSS, very easy. And once you got it, you turn it on. There are a couple of pop-ups here or there. Just close those until you get to Oh, by the way, here you can learn more about how to conduct um, a z-score, using SPSS. If you wanted to you watch that, you be my guest. Um, so this is how you do it. You open your SPSS, this page, at the bottom left, and again, if you have a Mac, it's in the middle. It says that variable view, and then data view. So variable view, it says name your variable. For now, uh, we just call them score. You can call them X. X means the score. You can call them data, whatever you want to. But later on, like in advanced statistics, we have different groups, different columns, and we have to name them different. But for now, this is what you have. Uh, anyway, you click on variable view, and on top, you call it score. Then you click on data view right there at bottom left side, data view, and change its color to yellow. And then you type in a bunch of numbers. Imagine, again, we wanted this to be realistic. That's how you understand. That's how I understand these stuff. If you just throw some number, oh, here's the Z, absolutely, it's meaningless. But assuming that you are a teacher, you teach a class and 15 students, it says that first column 1 to 15. And those score that you put in right there says score. Imagine these are scores from the student's exam. So somebody come to you, a student come to you and say, hey, doctor, professor, I know I did 78, but where am I standing in class? Is this good? Is that average? Or a lot of people did better than me? Or what's going on? Once you calculate the z-score, well, first of all, you need to know the mean for the class, right? X minus mean divided by standard deviation, and know the standard deviation. So you need to know the standard deviation, you need to know the mean for the class, and then it tells you the z-score for every one of these scores. These are x's. We did one. So again, these are all people, and a score comes from people, right? They score on something, some topic. Let's say that's the statistics. 15. All right, what do? We go to analyze descriptive and click on descriptive again. It says must click on save standardized value as variable. So what you do, all these numbers, guys, all these scores are attached to that variable that you named scores. It's here. It says right here. So what you do, you drag and paste it to the right side and move there. Or you click on it and click on this arrow and it will transfer it from left to right, one way or another. And then again, at the bottom, you see that check mark? It says save standardized value as variable. You click on that. And then again, if you click on other scores right there, it's not sure. Right there, click on mean. You want to know the mean for these. And again, standard deviation. That's all we need. And the variable list is automatically there. Leave it there. Click on continue and click on OK. So you have everything here. Um, Slideshow. As you can see, the mean for that distribution is 77.4. So somebody scored 78. They are slightly above the mean, but z-score tells us exactly how far they are above the mean. So 77 is slightly above the mean. Okay. And standard deviation is 14.881, almost 15 point above the mean. These are important for that class. If you click on that orange star right there, it says to see z-score. You click on it, and you see the z-score for every one of those scores. So the guy who scored 78 comes to you and say, how did I do? His z-score is 0.04, knowing that mean for this distribution is 77.4. So slightly, just a little above. And the guy who got 100 or 98, they were 1.5, like 100 is 1.5 above the mean. 98, 1.3. And the guy who got 58, 1.24 below the mean. That's negative, below the average guy. The guy who had 59, okay, right, 1.24, 59, all right, 99, 1.45 above the mean. So this is how you can tell that who's who, where they stand, and they can tell. Again, you in a class which very difficult exam, which majority score 70. If you get 80, you did great. Maybe that's the highest point, but you need to know where you stand in the class, in the distribution, and that's the job of z-score. It tells us exactly where all these students, 1 to 15, are located in that class distribution of their exam. So that's about it for z-score. So please read the sample review questions for the z-score and take your next quiz, which is on z-score on Blackboard. And next time, we're going to talk about probability, and which is continuation of the z-score. We will talk about different z-score, the one we talked and the one for the sample. The first part here is really fun part. And you can read it on your own. We're not going to spend too much time. It's some real data, real facts about probability. We're going to go over that, all that. And these are all the formula you need. And on top, that's the stuff we talked about today. We're going to go over that again. Get ready for the probability. At the bottom, probability has its own formula. P stands for probability. The formula is F over N. The frequency, and then explains our number divided by total numbers times 100 gives it standardized. And so these are the critical value for the Z-score that we're going to go over next time. It's better to have a book, textbook, preferably the one I have, or any will help, any others, better than not having. So these are all critical values for the Z-score. You need to have access to them. That's why it's important to have a textbook. Then there is a Z-score calculator. You can help, maybe double check yourself when you do your um, quiz or, or exam or you uh, even homework. So yeah, that's what we're going to talk about. It's more about spatial ability, different location of the Z, like it says, you know, um, zero point 0.5 above zero point 0.5 or below zero point 0.5 z-score of zero point 0.5. Above, you go to the right. Below, you go to the left. That's just to give you a heads up what we up, what you up against next time. And then we do again another uh, SPSS that we will cover this next time. All right. Please let me know if you have any question. The best way to communicate is to email me with the problem or question that you um, wanted to know. Once again, please make sure this SPSS is very important in real world. In real world, you not gonna do any kind of manual calculation. You are gonna use SPSS. So it's better to learn how to work with the SPSS as soon as possible. Other than that, have a great week and wait for my next presentation.